Hello, I'm Dr. Priya Hasan and welcome to our second lecture on astronomy data. Now in the previous lecture we spoke about astronomy archives, where we basically spoke about what is astronomy data, what is the kind of data you could have. You could have images, spectra, time series, catalogues, etc. And these astronomy archives are basically systematic observations of the sky, which have been kept and preserved since a long period of time. Now, astronomy archives are in the true spirit of science, basically because you have a whole lot of data available to everyone. And as this general principle which is done, if you have a telescope, what is generally done is that initially the instrument groups have access to the telescope because they are trying to calibrate their instruments, check the, the behavior of their instruments. And after a certain time, even if people apply for projects and they say they want to observe using a certain telescope, for a certain period, for often 18 months, it's called the proprietary period. The observer, the proposer who proposed to observe, he actually has the data. And after an 18-month period, the data becomes available to the community. And basically, the community is free to use the data for whatever they would like to do after the 18-month or the proprietary period. Now, the advantage in this being is that if you have very good, high-quality data, and people have actually used it for a certain purpose, with a certain problem in mind, the same data can be used by many more people in another way. And this is basically to encourage people to get out the maximum they can get from this data. Now, the archival data is often of very high quality. So typically all space telescope data, whether it's Hubble or Chandra or Kepler, TESS, whatever you'd like, all the space telescope data is archived so that you can have it. So it's very good quality data. And also a lot of ground-based telescopes also have their archives. So all this data is very good quality data, which can be used for, a very good effective purpose. And that's essentially what we are even going to study about in this course, where we are basically going to look about what is the different data that is available and how can we actually use this data to our advantage to basically study different problems in astronomy and astrophysics. Now, since there's so much of availability of data, people also encouraged what are called citizen science projects. Citizen science projects are projects in which you encourage non-astronomers or citizens to actually do astronomy projects. So for example, there was a SETI project, which is Search for Extraterrestrial Lives, where people could, extraterrestrial intelligence, where people could actually offer their computing power to analyze the SETI data. Similarly, the Galaxy Zoo experiment was an experiment where actually a large amount of data was available about galaxies. And what was required is that you wanted human intervention in actually classifying these galaxies based on their morphological type. Essentially whether they are spiral or elliptical or whatever kind of galaxies. And it's obviously not possible for a group of astronomers to do that. And hence what they did is that they did a certain initial training period for citizens, after which citizens could themselves opt and classify galaxy data in the Galaxy Zoo experiment. So basically this was to categorize different kinds of galaxies, put them into different morphological bins and study their properties. And this actually led to publications, official publications of the Galaxy Zoo data, because you actually got such a large number of volunteers or people to offer and help in this archival data. So I would say that archival data is the way to go ahead in today's times. Now, if you actually see, we can you can actually see that there are various data archives which are available. What are data archives? Data archives are basically locations where you're actually housing or keeping this data, right? So one of the most effective or the useful data archive is VizieR. I'm going to show you a demo of how to actually use VizieR. So VizieR is actually a place from where you can access various articles, as well as you can access all as published astronomical data and astronomical catalogues which have been given out from the VizieR database. And the other one which I mentioned here is Simbad. Simbad is an astronomical database which gives you basic data, cross identifications, bibliography. For example, you have a certain object, you want to know who else published articles about it. There is the NED The NASA IPAC Extragalactic Database for multi-wavelength fusion of data for extragalactic objects. There is a Sloan Digital Sky Survey which already has its data release 15, where you have a systematic map of a quarter of the sky producing new catalogues for the deep sky. There was the 2-mast survey, which was actually a map of the entire sky in the near infrared. Then the European Southern Observatory, they have their data archives where all their telescopes data is available on the website, and you can actually access the data and use it effectively. There is the MUST, or the Multi-Mission Archive at Space Telescope Science Institute. This is basically, it houses not just the Hubble data, but also houses data in the ultraviolet, the galaxy data, near infrared, and various other data sets are also housed in the MUST data set. There is the 2-degree field survey also, which has a spectroscopic survey for a lot of galaxies. There's also the IPAC, or the IRSA, which is NASA's infrared and sub-millimeter astronomy database. And we're going to have a talk on the 29th of August by Luisa Ribul, who works at the IPAC IRSA. And she's basically going to tell us much more about the IPAC IRSA database. There is the Hubble Legacy Archive, which optimizes science from HST, providing enhanced Hubble products, browsing capabilities. So there are various data places. So the idea is basically to know where are these different data centers where one can actually access data. So I would encourage you all to individually look at these various websites, which I'm mentioning over here, and actually see how to use them. They are all pretty, user friendly, and it's just a little bit of practice. If you have on some of the data sites, you'll actually know how to use it. So for example, the Multi-Mission Archive Center, which you have over here, you have, this is the Hubble Space Telescope. This is the upcoming James Webb Space Telescope. That's the TESS. This was the sequel to Kepler, and K2, which is actually the Kepler mission, but in the second phase, the K2 mission. So you can access all these data sets from this website. There's also the Hubble Legacy Data Archive, where you can actually access from here. Again, you can have a look at the website and you can actually see how to access it. You see, you can give the position of objects, you give the radius in which you are searching around the object, and you can actually choose the instruments you are looking at, which ones you want to form, and etc. And in that way, you can actually look at this archive. The other archive which I'd like to show you would be the one that we have over here, which is coming up. Which is over here. So like I mentioned, the MUST archive has Hubble, Kepler, Galaxy, Fuse, etc. And you have the Hubble Source Telescope catalog, and you have various catalogs also available at this website. The latest website, which is the most useful one, which is the ESA satellite, which is Gaia. It basically offers for the stars in our galaxy, a billion stars in our galaxy. It basically gives you astrometry, very perfect positions. It gives us parallax, which actually gives us distances. We'll talk about parallax tomorrow, so you'll know what's parallax. Radial velocities, proper motions in RA, proper motions in DEC, and various other parameters. And basically, this is a satellite which has 2 mirrors with which it is actually very accurately measuring positions and motions of a billion stars in our galaxy, right? And this can be directly accessed from the VizieR site, from the Gaia site, which is ESA Gaia, as well as we will have separate sessions where we will talk about specifically Gaia and how to actually access the Gaia data. India has a GMRT, which is the Giant Meter Radio Telescope, which is in Pune. And you can actually see that the GMRT also has an online archive system. So you can actually look for things based on the proposal code. Supposing you knew what was the proposal, people observed it and the time. So for example, if you pick up a paper in radio astronomy, which has observations from GMRT, where you have the proposal code and you would like to work out the paper, try to do it for yourself, you can actually put in the proposal code, get the data, and try to analyze the data the way it is described in the paper. And then it could also be possible that while you are analyzing it, you realize that it could be done in a different way, or in a much more intuitive way, which can give you a certain result. And you can kind of play around with the archive in that way. So this is the GMRT archive. Chandra is the X-ray telescope, which is still operational, which is which has its own website. And from the website, you can actually access the archive. You can see it over here. This is the archive. There are various tools which can help you to actually search and retrieve data. So for example, Chaser, etc. And they are very, very good helplines on these websites which actually tell you how to handle the data and what exactly can you do with the data and what are the kind of results you can get. SDSS, I already mentioned to you earlier. This is called the Sloan Digital Sky Survey, which actually has the most detailed three-dimensional maps of the universe ever made. And this is already into this DR15. And you can see over here that if you go to the Sloan website, you can actually look at the data, surveys, instrument, and collaboration, education. And you can actually see the publications that people have done using this thing. So spend some time looking at the SDSS site. And the other thing I wanted to now end with is a short demo on VizieR, which I will show you. But before that, I'll talk about the data archives itself, that we are going to have individual sessions about each of those data archives, which I mentioned to you, whether it's Gaia, whether it's the Musk data survey, whether it's Chandra. I'm going to actually show you demos on all of them, for many of them, we are trying to actually get people who are over there, working over there with those data archives to actually talk to you and tell you things about them, right? So after that, I'll talk to you about the VizieR catalog, which is the literature survey catalog or data survey. I'll do that next, in the next video. Thank you.